and welcome to the Chief Science Officer Zoom In on Science Calls, where we learn about STEM professionals' careers and the impact of their job in modern life. For all of us to enjoy this experience as much as we can, please don't forget to mute yourselves. And on the past calls, we have learned about a lot of different things, ranging from oceanic creatures to our own mind and bodies. So to keep up with us learning, while we are all here quarantined and welcome, Eric Miller, the CEO of PADT, is going to talk to us.
Everybody, let me share my screen. My name is Eric Miller, and I am what is called a mechanical engineer. And so mechanical engineers are people who design hardware and physical things. And what I'm going to talk about today is about being a mechanical engineer today. We call it Mechanical Engineering 3.0. 1.0 was pre-industrial revolution when they didn't call mechanical engineers, but the guy that would chip the rock into a wheel and turn it into a wheel. That's engineer 1. Engineer 2 was kind of in the industrial era where we started building these big machines and trains and massive bridges and things like that. And then 3.0 is kind of the digital world where we make physical products and they all have electronics and software embedded inside. It's just kind of a cool time to be alive if you're an engineer. So a little bit about myself. Like I said, my name's Eric Miller, and that's a much better looking picture of me than I look like right now, but COVID. I'm co-owner and principal of a company called PADT, which I'll talk about next. And what do I do? Well, I think most of my time is actually spent as a small business owner. I don't do as much engineering as I used to, but we have an 85-person company, so running that company with my 2 partners is a lot of my job. I do get to go do engineering. I just did some right before this call, and it was fun. I'm also a speaker and a writer on things technology, especially 3D printing. I mentor startups and young engineers, as well as host a very niche-y podcast about a piece of software that we sell. It's called All Things ANSYS. I host that, and then I'm also a sitter on boards of different organizations and things. So my background is I grew up the child of an Air Force pilot. Anybody else grew up Air Force or military brat? Let me raise their hand. I'm the only one. You did. So yeah, I grew up, it's kind of a fun lifestyle. You get to travel all over the world. I mostly lived in Arizona as a child, but we were able to live in Italy and Germany and Virginia and Turkey. And then I ended up in California, where I went to high school in Sacramento, and I graduated in 1986, which is a very long time ago for you guys, with a degree in mechanical engineering. And I have to say that going to university was the best and the hardest thing I've ever done in my life. So I was a pretty good student, and didn't really have to work too hard to get good grades in high school. And then I got to university, and it was so much more challenging and so much more fun and so much better for my brain. And I loved it. It was fantastic. I wish I could have stayed there my whole life, but I wanted to get out and do things. So the other question is, why did I become a mechanical engineer? Everybody else wanted me, my family wanted me to be a doctor. I wanted to do something a little bit more creative. I loved science, and I loved being creative and making things and using the creative side of my brain, but also using science and math. And that turns out to be what kind of mechanical engineering is. It's applied physics, right? So we get to be creative, we get to solve problems, we get to invent new things using physics and some other science as well. So that's kind of why I thought, well, you know what, I'm going to try this out, see if I like it. If I don't like it, I got a degree in mechanical engineering, I can do something else. And I've stuck with it now for 30 some years. And I've always wanted to build something that's kind of community as well. That's kind of important to me. And so one of the reasons why I left my corporate job making turbine engines or designing turbine engines was to create a community for engineers like me a place where they wanted to go to work. So we created this company, PADT, as kind of a place for engineers who thought and felt about the world the way that my partner and I do to go to work and enjoy themselves. And that was 26 years ago. And I also do a lot of work out in the community and with the Arizona Technology Council and the SciTech Festival or Foundation now, things like that. So I like to be involved in the community as well, whether that's a community we created or the broader community. So what's my current STEM position? I consider myself an enabler of innovation. So what is innovation? Innovation is saying, I've got a problem, here's how I'm going to solve it, or I'm going to do something new and different. And so I'm not really the guy that comes up with the answer. I'm the guy, and I have employees especially, who are the people that figure out how to take this innovative idea, like, oh, I've come up with a new way to pump blood that doesn't damage the blood when it pumps it, right? Because when you take blood out of the body and you pump it and clean it and put it back in the body, it actually damages the little blood cells. So doctor came up with an idea of how to do that, but he's a doctor, he doesn't know how to do engineering, so we helped him turn that idea into a product. And I run a company that leverages computer-aided engineering tools to design and build products. So the first thing we do there is, and this is my background and what I love to do, everybody likes to talk about 3D printing, but I think what's much cooler is simulation. And what we do in simulation is we build mathematical computer models for the real world. And we also call it virtual testing. So this is a good example of a Apache helicopter, and it's got antenna all over it, and all these different radios and things have to talk to each other, and they might actually interfere with the spinning metal blades, or they may interfere with each other. So this is modeling, what does that antenna signal look like, and how do the different antennas interact with each other? That's the kind of stuff we do, whether it's fluid flowing over the blades, or whether it's how strong the landing gear is when it lands really hard. So we build computer models to simulate that, and it's a lot of fun. It's kind of like playing really, really realistic video games. And hopefully nobody dies. You don't respawn, so. The second thing we do at PADT, that I do, is design. And this is really also part of my background, strong background. And this is where we take people's needs and turn them into physical products. And we also call it product development. That's another word for it. And this is a good example of a whole family of products that we designed for hydrogen-powered cars. So right now we use gasoline and electricity to power cars. And gasoline, we know it has a big carbon footprint, and it's dangerous, and it's not a good chemical for the air, and harvesting oil from the ground isn't the greatest thing in the world, and it's expensive. So we want another alternative. Electricity is a good one, but you still kind of have to generate the electricity. You got to transmit it. You got to get into the car. There's a lot of losses. Turns out the most efficient way to run a car is off of hydrogen, because when you burn hydrogen, you take hydrogen and you take oxygen and you combine them and you make water and heat. And that's what we do in a hydrogen vehicle. And we actually use a fuel cell to do that. So we, instead of generating the heat, we make water and we get an electron, and that electron powers an electric vehicle. So replace the batteries with a hydrogen fuel cell. And we're specialists in making the blowers that move the hydrogen into the fuel cell or into the engine. And so that's kind of a cool part of what we do. And we've done probably 10 different projects on hydrogen powered cars and buses over the years. And it's a lot of fun and a significant engineering challenge. So we love hard stuff. And the last thing we do when we enable innovation is the 3D printing. And that's really, I think most of you guys know what that is. You may probably even have one at home or in your classroom, but it's going straight from the computer model to a real part. And we also, the broader term for that is freeform fabrication. And so our company doesn't make maybe the printer that, or sell the printer that you have at school. We make we sell really big industrial computers, 3D printers. So the one in the picture right here is kind of a mid-sized one, and it does parts about a foot by a foot by a foot. And then we have bigger ones that get much larger, like 2 to 3 or 4 times that size. And we make a lot of fancy, difficult to manufacture parts. We even do metal now, which is really cool. So we 3D print metal. It's a lot of fun. So what's kind of a cool thing that we're doing right now to share with you guys? And I think it's a great example of 3D printing strength, and that's making personal protection equipment for hospitals. So as you know, there's a shortage. If you've ever watched the news, they talk about it all the time. There's a shortage of not just masks for people's faces, but also they like to wear a plastic shield to keep basically spit from getting in your face, right? And so there's a shortage of those. And one particular hospital chain here in Arizona had a very specific desire. They couldn't really buy the one they wanted. They had a different design that they wanted. And so we designed it for them. We helped them figure out, we talked to the doctors and the nurses and what do they need in order to treat people on ventilators. And we designed some special products for them. And then we immediately started printing them. And what's kind of cool is this is the finished product over here. You can kind of see it. This is Kai. He has a PhD in material science, and he was able to apply that in order to figure out what material would work best in this environment so they could clean it, right? Because you can't just take, say, we use the printer that you guys may have at school. It prints PLA. If we put that into a sterilization machine, it'll just melt. So he had to use his background to figure out what materials were needed in order to make it. And then this is Savi over here, and he's a technician, and he builds stuff basically for us. And so he's the one that's putting all these together and making sure they're fit nice and everything. And then this is Renee, who's actually a salesperson. And this is what I love about this is you know, she's usually out talking to people about, hey, let us make parts for you in 3D printing. But instead, because she's been trained to run the machines, she runs the night shift on the machine. So we run 3 shifts to make these shields. And so Renee comes in after dinner, and she loads up the machine and kicks off a new run. And you don't have to be an expert to run these machines. Now, what's cool about these machines, they're not like the kind that kind of squirt out of plastic. It's the fastest machine on the market. It's called a carbon digital light synthesis machine, and it shines light onto the bottom of the liquid down here at the very bottom, and it pulls the part up continuously. So instead of doing one layer at a time, it pulls it up. So this part only takes about 20-30 minutes to make versus, you know, several hours on other machines. And then this is David, our IT guy, who was helping them put stuff together as well. So I think one of the things I like to point out is, you know, we got stuck in this mess where there were a lot of people getting very sick and a lot of people trying to help them that didn't have the protection they needed. And in order to spin up a factory to make those parts, it's going to take a couple months. And this is where 3D printing just was perfect, because anybody with a 3D printer can download the design. They don't have to be an engineer. They don't have to be an expert. They can download the design and start making these parts. And that's what everybody did. There's a group here in town that was started because one of the sons of a dentist here, he had a 3D printer, and he's like, I want to make shields for hospitals. So they got a group of other people together and some schools, and they're all making shields and giving them to the hospital. And then large companies are making them as well. So it's a great application of the technology, because we can make a lot of parts really fast, and they're more expensive. But once the factory's up and running, we'll make them in the factory. But while we were waiting for the factory, we were able to solve this problem. So saving people's lives with 3D printing.
So thank you very much for telling us about your job, and I think it's really cool that you guys are 3D printing masks for the hospital. While we were learning about what you do, participants have left some questions in the chat, but I'm first going to ask some preset questions that we made.
Sure.
So the first one is, what is your favorite part of your job?
My favorite part of my job is the variety of problems I get to work on. I love that. So I'll come in one day and we're talking about one of those hydrogen pumps that I was talking about. And we're working on a medical device that allows wounds to heal faster. And then we're also working with Los Alamos National Lab on a way to hold a stable laser really stable, so they can shoot it like 2 miles down a tube and hit this target 2 miles away, and then see what comes off when they hit it with this high-powered laser. And that's all in one day, like one meeting after another after another. And I just yesterday was one of my favorites. We were in a meeting discussing how to simulate a lander on Venus. So you guys know the Mars rover, the guy that's running around Mars? They want to take that and put it on Venus, but the problem is Venus has so much pressure. It's like more pressure in the bottom of the ocean. So how do you design and build something where you can't test it? So we're going to use computer modeling to do that. And so that was just super cool. So the variety definitely is my favorite thing.
What skills do you have to apply in your job?
My job now, because it's also running a company, is working with and communicating with people is probably the biggest skill. On a technical side, I write a lot of software, even though I'm a mechanical engineer. In fact, the engineering I was doing right before this call was writing a little piece of software that takes information from one of those simulations and puts it in a spreadsheet and then puts it on a website so the customer can see the results. So I do a lot of software development. And then we use math all the time. I don't know if you guys have started taking calculus yet, but one of the things you'll hear when you take calculus is, "You'll never use calculus ever in your life." We use it every single day, whether it's figuring out the volume in a 3D printing job or all of that numerical analysis stuff we do is calculus. And then in the design side of things, we use calculus all the time to figure out how to solve problems. So yeah, math is a really important skill as well.
Okay, so my last question here is, what advice would you give to your 14-year-old self? After this, I'm gonna take some questions from the chat.
My 14-year-old self. Hmm. I think don't be afraid to ask. I think the biggest thing that I did wrong when I was young is I was afraid to ask. And this is not just about engineering. When I was a little bit older, afraid to ask out that girl I really liked, right? And so find out after a year of not asking her out that she really wanted me to ask her out, right? That's a great example. But from a science and engineering standpoint, you know, sometime, and you guys may deal with this too, my classes really weren't all that challenging, right? They didn't have what I needed, and I was afraid to ask. I kind of already know this. How can I learn more? I waited for them to say, "You look bored. Why don't you do these extra problems?" And if I would have asked them, "Hey, can I do a special project? Can I go, do an experiment? Because this stuff's, I already know this stuff." I think I would have learned more and had more fun and really been more engaged in my school days. Um, and so, yeah, I think that would be the advice I give myself is don't be afraid to ask. The worst thing anybody's going to say is no. And it took me, till I was probably 30 to realize no doesn't hurt. No is just no. Go do something else. So that's the advice I give.
Okay, so I'm gonna take some questions from the chat now.
Okay.
So, what is your favorite part about hosting an Arizona SciTech Festival event for the community at PADT?
Seeing the look on kids' faces when they go in. So, I'm an old guy, right? Sometimes I lost some of my amazement at some of the stuff we do. And to see it on people's faces when they pick something up that we've 3D printed, or we're showing them maybe a simulation that we did, or some of the parts we designed, and to see how cool they think it is. It's like, I forgot it is really cool. So that's my favorite part. That's definitely my favorite part.
And that question was from CSO International. Now from CSO Josh, what is the best path through high school and college to become a mechanical engineer?
Hmm. I think that really depends on you. So mechanical engineering is a very broad thing. You've got to have the basics that they're going to make you do it. If you're doing college prep, you're going to take math, you're going to take science, you're going to do all that. I think if you're going to take extra classes or you're going to focus on where you're going to do AP classes, get the calculus out of the way early. So you can take more advanced calculus. So I ended up, we didn't have AP when I went to school. So I ended up having to take all those classes. So I was in math for 4 years. And there was some other stuff that I would have loved to have taken that I didn't because I needed the math. So, get the AP physics, AP math. And then if you've got engineering type courses in high school that are just kind of basic fundamentals, I would definitely take those as well, like a robotics class or something like that. It really helps. Anything you can take that teaches you to work in a group is also beneficial because that's the way they educate now in college. They do everything as a group. And so if you already know how to work in a group, which you guys are learning as CSOs already, build on that. You'll definitely be able to do better because you're working on group projects, and it doesn't matter how smart you are, you're only as fast as the slowest guy in your group. So helping that person be faster is something you're probably learning now and you need to emphasize.
Okay, so from CSO Lauren,
Mhm.
how can one get an internship with an electrical engineer?
Okay, so in high school or in college?
I'm guessing that, well, can CSO Lauren tell us, because it's about her
Mhm.
sister,
Okay,
if she's still here. Well, I don't know.
if
I'm
she is,
just gonna
yeah.
guess it's college.
Yeah, so I think what my sister would like to know is when's a good time to start taking internships and when
Mhm.
she's looking around for them, what kind she should take or how she should ask, who to look for. If there's any advice you have from your
Yeah.
experience as an electrical engineer and looking for people to take internships from. Thank you.
Yep. So if you are still in high school, you might be able to get an internship as a tech. So you're not going to be able to do engineering, but you might be able to do soldering and assembly and quality and things like that. So don't be afraid to ask. So go to the big companies. They're going to be more likely to have an internship program that's large, and you just take anything that gets you exposure. And then once you're in college, definitely start after your freshman year. And it's not going to be challenging. They're not going to get you don't have the classes yet to go design integrated circuits, right? That's you have to wait till you're a junior, right? But as a freshman, just finish up your freshman year, there's a lot you can do and there's a lot you can learn. And so I highly recommend just reaching out. And like a mechanical engineering, electrical engineering's got a lot of different areas. So you may not know early on which type of electrical you want to do. So just apply anywhere and that'll help you decide. But I recommend the bigger company. And the other hint I will give you is if your parents are technical or know technical people, ask them to ask. So I got a stack of 20 kids that want to be interns, right? And I'm going to go with the guy that you know I know their mom, right? I'm on a committee with their mom. Their mom works at Intel, and I'm on a committee with their mom. So I'm going to pick that one because their mom's smart and capable, so maybe they are too. It's best. That's all I know. So if you've got connections, use them. Don't be afraid to just ask your parents, hey, do you know anybody that might be hiring? And can you reach out to them and ask them if they have an internship program? And that'll float you to the top of the stack.
Thank you
Okay,
so much.
so there are three more questions.
Mhm.
Um, as a leader, what is your personality strength, and what do you have to continue to work on?
Wow, that's a really good question.
And that's from CSO International, by the way.
I think that my biggest strength as a leader, if you ask my employees, I think it would be communicating clearly to them. So letting them really understand what I want or what needs to be done or what's going on. I think that that's the thing that they tend to rate me the highest on when we do kind of ratings is that I communicate well to them. I think that's my biggest strength. Um, my biggest weakness, it kind of goes back to the whole thing of don't be afraid to ask a question, is I hate conflict. And so I avoid it like the plague. And it's not a good thing to avoid it because it's not going to go away. It's going to still hit me in the face. So that's the thing I've been working on the most is um, just toughen it out and dealing with the conflict and telling an employee they did something wrong is better for them. Not telling them is not good. And I'm afraid of upsetting them and they're going to be mad, but it's better just let them know, you did that wrong. Here's why. Here's what we can do to fix it next time.
Okay, do you ever use recycled materials like plastic water bottles to 3D print with?
We do not.
From
So
CSO Sophia.
yeah, so we use industrial 3D printers, and none of the recycled materials yet have been approved for those printers. They're higher temperature, and so it doesn't work. What we are working on, and this is a little more obscure, but taking composites, so carbon fiber composites, from things that are, so there's a company in Colorado that takes those composites and recycles them and then puts them into 3D printing filament. So working with them to find a way to use recycled carbon fiber in our 3D printing. But that's right now, Yeah, it's not really an option for us. We're working on it. Probably more from a recycling standpoint is we make the machines that actually clean the parts. When they come out of an industrial 3D printer, there's this support material underneath, and it's water soluble, and it's kind of nasty stuff. And so we make the machine that cleans that material off. And then we've got a project with University of Arizona to come up with some chemicals that'll separate out the nasty stuff. And then we can recycle it and use it again.
Okay, last question. Claire asks, where in Sacramento are you from? Because she also lives there.
I am from Land Park. I went to McClatchy High School.
Nice. Okay.
So where
Thank
the zoo
you
is.
very much.
If you don't know Land Park, it's by the zoo.
Okay. Thank you very much for your wonderful contribution today. Before we close off this call, what advice would you give to us as young leaders for our future?
Well, first, thank you for being leaders. That's the best thing. You took the first step. You know, I guess advice, everybody's different, but, you know, the advice I give everybody is be less selfish. I don't know if you are selfish, but I think as a humans like to be selfish, and it's easy for us to be selfish. It's kind of our natural state. And I think if you want to be successful in your career and make a difference in the world, it really starts with looking at the bigger picture of what you can do that's win-win for everybody and not necessarily just for yourself. And that's the advice I give, whether you're a student or a CEO of a large corporation. That's the advice I give.
Again, we thank you very much for all this information about you and your company. We will be sure to send you a proper thank you email.
Well,
we hope that you can participate in another call someday and help us continue zooming on science. Like the motto says, don't just hope it happens, make it happen. So I'll see you guys soon.
Thanks, everybody.
That was incredible. Great job, guys.
Thank
Good
you,
to see
everybody. Great
everybody.
questions.